So redox reaction, there are 5 types of reactions. Redox reaction: combination, decomposition, displacement, double displacement, disproportional reaction. And we have learned these types of reaction in 8th class. There are so many reaction in which metals combine, atoms combine together form new compound. Decomposition reaction, when and compound break into different elements and ions or small molecules compound. Displacement, when one metal kick out the least stable metal from its salt and form new compound. Same with the non-metals. Double displacement, where double displacement reactions will be there. And disproportionate, when compound break into smallest compounds or molecules in a disproportionate way, means there is no fixed proportion was there. Okay, so first is combination reaction. A combination reaction may be denoted in the manner A plus B, that is equal to C, means an atom A and B combine to form a new compound, that is C. So either A and B or both A and B must be elemental form from a such reaction to be a redox reaction. So for example, carbon, whose oxidation number is 0, combined with oxygen molecule whose oxidation number is 0, and together, when they combine together, they'll form CO2, the carbon dioxide. And you can see here the oxidation number of carbon is +4 here and -2 oxygen here. Same with the magnesium. Mg 3 Mg N2, Mg3 N2 form, oxidation number 0, 2, 2 and 3, -3. Same with the methane one. So combination reaction, we used to see that there is a change in the oxidation number. Elements combine together to form a new compound which shows a new oxidation number. Next is the decomposition reaction. Decomposition reaction is the opposite of the combination reaction. Precisely, a decomposition reaction leads to the breakdown of the compound into 2 or more components, at least one of which must be in elemental state. As you can see here, this is the opposite of the combination reaction, where Mg and N2 combine together and form Mg3 N2, right? And but decomposition is like where the compound break into the simple molecules or elements. KClO3, KCl plus 3O2. Here the oxidation number is +1 to +1, and Cl with oxidation number 5 here, +5 here, and here the oxidation number of Cl is -1, and oxygen -2 to 0, right? Disproportion reaction. These are a simple type of reaction where an element is one oxidation state is simultaneously oxidized and reduced. Okay. One of the reacting substance in a disproportion reaction always contain an element that can exist in at least 3 oxidation states. The element in the form of reacting substance is in the intermediate oxidation state. For example, this H2O2, two molecules of H2O2 just decompose in and form H2O2, means a water molecule and an oxygen molecule. So you can see that there are two molecules of hydrogen peroxide here. One is reducing, means one get oxidized and one get reduced. Where with which the oxide means water form, that is oxidized. This is oxidized means the oxidation number is changed from -1 to -2, and here this is reduced from -1 to oxygen from a 0 oxidation state. Okay. So hypochlorite ion formed in disproportion reaction oxidize the color bearing staining of the substance to colorless compound. Fluorine is the most electronegative element and hence it can exhibit any positive oxidation state. Fluorine does not show any disproportionate tendency. This is the exception of disproportionate reaction. Okay, and you can see one more example. The auto redox reaction is a reaction of reduction and oxidation that occurs in same substances, means reactants. For example, the reaction of chlorine gas with sodium hydroxide solution, means Cl, react with NaOH, sodium hydroxide, that form NaCl plus NaClO plus H2O. One is in where the oxidation number of chlorine decreases from 0 to -1, and here the oxidation number increases from 0 to +1. So what is there? One reduction is there, and in one what oxidation is there. There's another example of disproportionation is NH4 NO3 gives NO2 plus 2H2O, where minus 3 2 plus 1 means N with the minus 3, and the change in oxidation number of N is NO3 will become plus 5 to plus 1. Okay, so there is a change in the oxidation state. So this is not a disproportionate reaction. Disproportionate reaction require that same atom is both oxidized and reduced simultaneously. Means simultaneously in a single reaction, a same atom will reduce and will oxidize. So this type of, if you see these types of reaction, these are not disproportionate reaction. In case different atoms of different nitrogen are oxidized and reduced. In this case, we have different atoms. This we have two nitrogen here, one nitrogen and one nitrogen here. So one is oxidized and one is get reduced. So this is not a disproportionate reaction. So sometime teacher used to ask a question, among all of these reactions, which is disproportionate reaction and why? And among all these reactions, which is not disproportionate reaction and why? At that time, you have to tell why this is a disproportionate reaction and why this is not, right? And that is how you came to know whenever n single element oxidize and reduce simultaneously, that is disproportionate reaction, and when different elements oxidize and reduce, these are known as that is not disproportionate reaction. Okay. It is possible. Another example, chlorine is simultaneously reduced from oxidation state of 0 to minus 1 and Cl in Cl, and oxidized from oxidation state of 0 in Cl2 and plus 1 in ClO. Is this possible? This chlorine is oxidized and reduced simultaneously. This is a disproportionate reaction. The single element from 0 it becomes plus 1, and from 0 it becomes minus 1. Okay. There are another type of example is displacement. So there are two types of displacement reaction, that is metal displacement and non-metal displacement. In 8th class, we have learned that whenever a highly reactive metal kick out the least reactive metal from its salt solution and form a new compound, right? Or its salt solution. So that is known as the displacement reaction. Same happens with the non-metals. When one non-metal is replaced by the another non-metal, what happens? A new compound formed with new properties. So you can see the C in CuSO4 plus 2 plus 6 and minus 2 oxidation state is there. With zinc it's 0. And you can see when the displacement reaction takes place, ZnSO4 form with plus 2 plus 6 and minus 2 oxidation state, and copper from plus 2 it becomes 0. Okay. Same with the non-metal displacement. Ca with 0 oxidation state, H2O with plus 1 and minus 1 oxidation state, and when displacement reaction takes place, what happened? Calcium hydroxide will form CaOH O2 with oxidation number plus 2, minus 2 and plus 1, and H will attain at 0 oxidation state. So these are known as what? The displacement reaction, metal and non-metal displacement reactions. So now balancing of reactions through half reaction method. There are so many methods. The first is half reaction method. There are several steps. Assign first you have to write the balanced chemical equation. Okay, you have to balance the atoms, number of atoms, and then proceed further. So first assign the oxidation number to the species in the reaction. Second, find the substance oxidize and substance reduce. You have to find out which substance is oxidizing and which get reduced. Write half reaction for oxidation and reduction. Balance the atom that change in the half reaction. Determine the electron transferred and balance the electron between the half reaction. Combine the half reaction and balance the remaining atom. Check your work and make sure that the atom and charged balance. Charges must be balanced. For example, I have to see these reactions. H2S plus NO3 negative plus H positive gives SNO and 4H2O. MnO2 plus 4HBr gives MnBr2, Br2 and 2H2O. First, what we have to do? You have to assign the oxidation state and you have to find out where the reduction is going on, where the oxidation is going on, which is reducing agent and which is oxidizing agent. So you can see that the in H2 is oxidation state is +1 and -2. In NO3 +5 and -2. In H positive is 1 plus. In S0 -2 -2 and H2O +1 and -1. Reducing agent is H2S, oxidizing agent is NO3 negative. Reduction is in H2S to S and oxidation is in H2S to S and reduction is NO3 to NO. Okay. Same with the MnO2. Oxidizing agent is MnO2. Reducing agent is HBr. Oxidation is HBr to Br2. MnO2 gives MnBr2. The reduction is this. So now how we can balance this? First step is assign oxidation state and determine element oxidize and element reduce. We have find out. For example, if Fe2 positive, MnO4 negatives give Fe3 positive and Mn2 positive, we have find out this oxidize and this get reduced. Okay. Now separate the oxidation half reaction and separate the reduction half reaction. You have to separate out the reaction and what reduction reaction. As you can see, Fe2 will form Fe3 and MnO4 negative to Mn2 positive. I just separate both the reaction. Now what happened? Let's see the balancing. Okay, first balance the atom other than oxygen and hydrogen. Other than oxygen and hydrogen, you have to balance other elements in that reaction. Then you can see this MnO gives O4 negative and Mn positive, Mn2, Mn positive. I have balanced. Now balance oxygen by adding H2O and cite the lack of oxygen. Now what I can say that if I have to balance this oxygen, then I have to add H positive ion into this. So MnO4 negative gives Mn2 positive, 4H2O. Now finally add H positive by adding H positive and then side like the H2O. Why H positive? If lacking of H positive is there, so I have to add some H positive into the reactant side and MnO4 plus H2O positive give Mn2 positive and 4H2O. Okay, so that is an example. Write a balance equation to describe the reaction between zinc metal and aqueous lead second nitrate. Okay, so now you can see zinc with oxidation state 0, Pb plus 4 plus 2, N plus 5 and O minus 2 form Pb plus Zn NO3 plus 2 plus 5 and minus 2. Now just separate out the reduce means oxidizing reaction and reduction reaction, and what you have to do finally you have to add after adding these and this you have to add this reaction. Okay, next is write the balance redox reaction of MnO4 negative in acidic solution with H2SO3 resulting the product of Mn2 positive and SO2 negative. What I have to do, I have to just separate the reduction reaction and oxidation reaction. That balance the H positive ion and oxygen by adding water and H positive. Same with this oxidation reaction. After that, if I have similar means these electron and these are just removing by this and accepting by this in this oxidation. What happened? Electrons remove and these 10 electrons are accepted by this reaction. MnO4 positive. So you just cut it off and just write down the final reaction here. Okay, so there are different methods you can find it out. Next is balancing the following redox reaction which occurs in acidic solution. So there is some difference. In acidic solution, we have to add H positive. In the basic solution, we used to add OH negative. So see, you can see H positive 14, H positive will be added to balance this 7H2O. And after just separating out oxidation reaction and reduction reaction, and we after balancing, what we'll get, we used to add 14H positive to get 7H2O. This is the balance reaction. Okay, next in basic solution, SO32 negative MnO4 gives SO42 negative and MnO2. Just well separate out the reduction and oxidation reaction. You can see that there are HOH negative ions added which gives 3H2O. Means there is the reaction in which OH negative will be added to the product side. That means on the reactant side, and we'll get the H2O molecules. After this deleting these electrons, what you will get? You will get the balanced chemical equation. So first step is you have to write the balanced chemical equation. Second is you have to see the number of atoms and molecules, the balancing is there. After that you have to see that oxygen is balanced or not. If not, you have to add some water. Secondly, you have to see the reaction is taking place in acidic medium or basic medium. If acidic medium is there, you have to add H positive ion. If basic medium is there, you have to add OH negative ion to complete your reaction. That is how we used to balance the redox reactions. Okay.